I'm here to talk to you today about Holochain, and in particular, a certain architecture we can do with Holochain focused on integrating it in with other blockchain technologies. All right, hands up if you know about Holochain. There's some people, there's some not people. All right, I'm going to spend maybe 5 minutes on just a very high-level overview of Holochain. And again, this talk is a non-technical one. It's to give you a sense of the technology and what we can do with it. So it is a open source framework for building peer-to-peer applications. And one of the things I love most about this technology is it took deep inspiration on how nature coordinates and how nature is organized. And it's a very refreshing and different approach to decentralized computing and peer-to-peer coordination. And lots of it comes down into the inspiration taken from the biological world. Another thing that is really important to know about this is it runs on consumer hardware. So it's not like you have to download a terabyte of data to run a local node, or you have to buy expensive gear for it. You can run it on small laptops, and people, when they're running it in a peer-to-peer way, that builds the network up itself. So consumer hardware it's something that is easy to think is not possible, but there's a lot of stuff you can do with just individual laptops, individual devices. And it's the people who are using the applications who are hosting this network. So it's truly peer-to-peer, it's truly decentralized, and there's a lot of social and technological implications that come out of these choices. This is a whirlwind 5 minutes, by the way, so wave your hands if you want me to go slower, and I can go down a bit. The security of the network is by peers countersigning and signing stuff with each other. And so there's a lot of implications around not having to manage global state, but the way of doing security is a bit different than you're used to in the regular blockchain world. The applications that are built, they can be public or private. You can control who joins them and who participates and the roles within them in a very arbitrary and fine-grained way. And as a developer, this gives me a ton of choices about the sorts of things I can do with these applications. So each application is a standalone peer-to-peer encrypted network. And that means that that application lives in its own right. It's its own network, and you can join it that way. Runs on the devices of the participants, and the thing I want to focus on today is the enforcing a shared set of rules. That when you can start to write an arbitrary rule set, which everyone publishing something agrees to and validates as true, then it starts to have quite profound implications on what you can trust in your systems. All right, that was backwards. So no servers, no blockchains, no tokens, no gas fees. It's a way of building stuff which is truly peer-to-peer. And I want to talk to you a bit. So I did a faster whirlwind than I thought of Holochain. So the thing I'd say next is that one of the most important things to think about in the Holochain world is that it made a very strong decision to not try and make global consensus easy. So instead of saying everyone in the world needs to agree with the state of our network, whether it's Ethereum or Solana or whatever it is, that everyone who's running a node agrees on that global state. By not doing that, and by making it so that apps can be independent of each other, each one has its state, which is isolated from other ones, and you can connect them if you want to, but you don't have to. You can run it fully self-sovereign. You can get this is the decision which made all the efficiencies, the data efficiencies, the latency efficiencies, all of that is a consequence of that decision. Within an application, you also don't need to do global state for the nodes. And this means that, again, you can build applications which can scale, I don't want to say infinitely, but like nearly infinitely. Like as the application gets bigger, as the user base grows, the people joining it don't have a heavier compute load because you're sharding it and decentralizing it amongst the network. So that means if you join a really popular Holochain application and millions of people are using it, you don't have to still download a terabyte to sync up like you do syncing up to the Ethereum node. You can just have your local piece of it and sync up in that way. So that not having global state has lots of big applications. And also, I realize this is a non-technical talk, so like just wave at me if you want me to not go into that level of detail. All right, that was Holochain in 5 minutes. Now I want to think about a particular application or technology. So in Australia, there's this thing called Renewable Energy Credits. So the government has set targets of renewable energy production, and it's essentially a subsidy they give out to energy producers. If you produce energy that's renewable, for 1 megawatt hour, you can earn a credit, which is something like $30, $40. but the wholesale price of electricity is something like $20 or $30. So you can nearly double the value of the electricity you produce if you are eligible for this credit in Australia. And it's an incentive for more people making renewable energy. And to get the credits, regulation, bureaucracy, audits, it is really useful if your solar farm looks like this. If you can have running utility scale energy production, you can get access to the system and you can get a subsidy from the government and it helps you out in that way. Not as useful if your energy system, if your solar production looks like this. One, the regulation doesn't make sense. Like the work to do to get accredited is not friendly to small producers. And also, the amount you produce is quite small. It takes these solar panels a long time to make a megawatt hour. But if they're selling energy back to the grid and they're getting double the price, that can make a big difference on how quickly they repay their solar installation. So this is the domain I want you to imagine of like, okay, this is the world and you want to build an application to help small producers, small generators get access to the subsidy from the government using a blockchain application. So who's a developer in the room? Anyone here build stuff? A couple of people? All right, and so if just think in your head, like how would you go about building that system? Like if we're going to use a blockchain, it's like, okay, tokenization, well that's easy, we can easily create tokens. Fractionalized ownership of the RECs, okay, or the renewable energy credits, yep, that's pretty known, you can start to do that. But the thing for me is like, how would you get it over the line where regulators and enterprise customers who are used to going to these wholesale exchanges to buy their RECs that are audited by XYZ, how would they see legitimacy in the work you're doing? How would they trust that when you say 100 households went and generated a megawatt hour of electricity together, that they actually did it? And that's the bit which is like, oh, layer 2s, cheap gas fees, it's still a really hard thing to do because there's just so much data. Because if you're trying to track, to get data to prove that this has happened, you're going to be talking about, okay, sensors measuring the electricity, people looking at the, claiming that yes, this person has the solar panels on their roof, energy bills coming back to them from the utilities, auditors, and all this energy you would need to track and all the data you would need to track gets quite big. And that just, large data sets don't really work well in blockchain worlds. And so you can build a centralized application, but what I've been focusing on for the demo for Holochain, so I helped build the stall that you'll see at the main event, where we're showcasing this technology, is how can you start to build a validated data layer where you can take large amounts of data and you can have arbitrary data sets, you can put them into a blockchain-friendly and amenable system, which is peer-to-peer, encrypted, decentralized, and a lot of the things we value in the blockchain world. And then how can you start to aggregate arbitrary data sets? So when I've been building this demo, it's focusing on like, okay, let's just measure electricity production and send data logs of that into the Holochain system. And if you're logging data every 10 seconds or 30 seconds, those logs get big. How can you start to like have customers say, well, here's my utility bill, and here's the energy company giving me a subsidy for my energy generated, and so on. You can look at the weather data on that day. You can look at people who said, yeah, they really do have that amount of solar panels on their roof, and the numbers stack up. So you can start to look at this data set and you can start to say, yeah, you can audit it and have faith that the credits that were issued on chain have some validity behind them. And the thing I want to point out about this is it's about, if you can make it cheap to audit, and so that anyone can go in and say, well, look, this issuer says they're issuing 100 of these credits and they're pointing to this application to say, here's the raw data to back it up, and it is cheap for someone to audit it, then there's a, yesterday I was hearing someone talk about that if you increase the penalty for breaking the law, people don't, it doesn't change how many people break the law or not. If you change the probability of getting caught, then you reduce the chances of people breaking it a lot. Because if you think you're never going to get caught, you don't really care what the consequences are. But if it's very likely you will be caught, it's much less likely people will cheat. And so cheap to audit, cheap to validate is what I think this system gives us, which is what I'm most excited about and interested in this particular use case. Another point before I move on is that this is an arbitrary system. What I think Holochain is exceptional at is building auditable, large, validated data stores and linking them up to blockchains with simple links. Because if you're putting like lots of validated large data sets into these networks, and you've got a lot of control over who can see them and how can see them, etc., then you can do whatever you want in the blockchain world, where it's really good at the tokens, at markets, at trading, and so on. So if you can get the validated tokens into there, you can do lots of stuff. And to link them up, you don't need to do much at all. Like in your on-chain world, you're just storing references to, this is a unique reference to the Holochain app which stores the data, and here's a unique reference within that app which points to a set of data that you can audit yourself, and so it's really easy on the on-chain implementation. And on the Holochain world, all you're really doing is storing like transaction hashes of saying, oh, here's a reference to some tokens on-chain. So the linking between the two systems is trivial technically, and I think combined they will really increase the scope of what you can do with blockchain and on-chain stuff. All right, 9 minutes left. So I started this slide and I was like, 2 Holochain features I really want to talk to you about. And I was like, nah, 3 features. I was like, okay, I'm stopping at 4 before I do a list. But I wanted to talk about what I think is, for people who don't know the technology that much, these are the things which allow me to build stuff that I can't imagine with other systems, or I can't do easily. Anyone see the Spanish Inquisition from Monty Python? How old is this lot? Okay, so yeah, some people, oh, it's still exciting, isn't it? Okay. Here's the first like feature which I just really love in Holochain. And like all systems talk about validation, like how do you make sure your data is what you want? But the way Holochain does it, and the way it means, there's the simple version I would say is that you've got lots of peers gossiping to each other, and they're sharing signed transactions and signed information. If someone in that network starts to like issue something which is factually incorrect, which people can say, hey, I've got a signed transaction log which makes sure this person's lying, they can share that, they issue a warrant for that node, and everyone can just start to ignore them. They get ejected from the network quite simply because you can prove that they broke the validation rules. And so by having the validation baked into the network, one, it kicks bad actors out, so it keeps your nodes, your peer-to-peer network integrity high. And also, it means that when you're writing applications, you can think about, okay, what must always be true for this to be valid? And having this set where I'm just thinking purely in validation mode, and then I can step away from that world knowing that the whole data set inside the application is sound, and then spending all my time thinking about usability and features and so on. So the validation in Holochain takes a little bit to learn, but I think it's an exceptional feature, and it's done quite differently than I've seen in other systems. Signals. This is the other thing in peer-to-peer systems, and like often I find when you're building blockchain applications and other sort of novel technology, it's really hard to create a great user experience. And having systems where you can start to have like just live updating and WebSockets type things, you have to do a lot of work to get the responsiveness in there when you're dealing with on-chain stuff where it's like 10 minutes for a new block to come through or whatnot. And even when you're going into the fast layer 2s, you're still constrained by that environment. So signals one, the thing about the signals is if you imagine a peer-to-peer, so everyone in this room, we're running a node. And if you know the address of someone else, you can build applications where those 2 people can start to have a direct, non-intermediated conversation. They can start to talk directly to each other, they can sign things with each other, which they can store privately, or they can share with the network. And that gives you incredible efficiencies and really low latency when you need it. Because often when you care about low latency, you don't care about low latency with like me to everyone. It's like me and you doing things together where you can have direct low latency things, which means that as I'm building an application, I can start to get these features in there which people just feel like, oh, it just works, and they kind of forget about the technology. Couldn't hear you, but I heard noise. Okay, another thing about Holochain, so feature number 3 that I love. Oh, wow, I'm talking faster than the time allowance. So countersigning. And this is the idea of when you are doing transactions in a blockchain world, and I want to buy something from you and you want to sell something to me, then we basically have to wait for the global state, for everyone in the known universe to agree that that has happened. And that takes a long time, and that's where a lot of the cost and that's where a lot of the delay comes into blockchains. Whereas if you and I can just like both sign transactions together and say, you sign this and I sign this, and then we start to publish it, we can start to do that in a way with witnesses when you need to, and you can get into more, you can do it very quickly and easily, which is a little bit less secure. You can do it a little bit more complex, which is more secure, but you can scale up the complexity and the security based off your use case. Because sometimes you're doing a transaction which is like, yeah, I'm selling you $1 billion of insurance, I want the whole world to agree, I want everyone to witness before I'm going to act on this transaction. And other times, I'm buying a carton of milk off you, and I really don't care about that much security. I'd like a finer grain of security, and having the ability to go up and down within an application is an incredible amount of flexibility. And so countersigning is one of the things you probably wouldn't have seen, and if you're diving into Holochain world, have a look at that feature. And finally, this is the one that I've used the most for the demonstration that we built for the Holochain, for the stall at the main event. Holochain's got this idea of capability tokens. And the thing which I get from this feature is I can now build applications which people who know nothing about wallets, who don't have keys and so on, can use this application. And essentially it is a way for a node who is fully empowered in the network, so someone who is running a full agent, they have keys, they're set up, they know a lot about Holochain, so a more technical sort of person, that someone can interact with that and the node can delegate actions to that person. So that's like a sort of complex mouthful in a way, but by giving them keys which I can generate and they can store in their machine, they're fully signing transactions. You can see who has signed stuff, you can apply validation rules to their actions, but you can do it in a way where they don't need to know anything about Holochain. They don't need to know anything about Ethereum or blockchains, and you can start to give them the ability to proxy into the network in that way. So it's incredibly useful for building like a mobile app which someone can just go to a website, start doing stuff, have no knowledge of our ecosystem, but it's starting to being recorded in these decentralized auditable systems. And it can be a stepping stone for people where you can take them on a journey of, oh, now that you've used this app a little bit, if you want to use the full feature set, well, here, go download something locally and you can go in that way. So that's one thing I get from capability tokens. Another thing, and this is probably a combination of capability tokens and validation, is that you can start, if you think about these agents who are all signing messages to each other and doing transactions and recording stuff in the system, you can start to build the validation logic where it won't pass validation unless it's signed by a user token. So if you think about logging into this account with an Ethereum wallet. So as part of the demo, I built a login with token proof. So you can log in, it proves you have the address, and then you can start to have transactions which are only valid in the Holochain world if it's signed by that Ethereum address. So every agent will look at it and go, hey, is this a valid transaction? And unless it's got a signature of that address, they'll say, nah, it's not valid. Which means no agent can act on that behalf. So these agents don't act like centralized server admins who can go and tweak the database on you. You can build validation logic which is only valid based off secrets that are held by users who know nothing about secrets. So the Ethereum one is an easy, like, okay, that's someone who's sophisticated and knows and set up a wallet and whatnot. But you can start to think about arbitrary secrets that your users have easily accessible. And that could just be like username, password that they make up on the spot, or an email or whatnot. Something which only they know. They can use that to sign transactions that the whole network will only validate if that secret is in the possession of that user. And so this flexibility with capability tokens to give new people access and also to make the agents a neutral. I think I've gone a bit technical again. Sorry for pitching this as a non-technical talk. Hopefully it's useful for you. That's the thing which has blown my mind most building this application in the last month. Is just like, that's opened up a world of stuff which I can't do in Ethereum. I can't do that in centralized land. There's this set of problems and domains and affordances which Holochain gives me, which is just really exciting. So that is, quick introduction of Holochain, a quick conversation about using it as an auditable data validation layer, which I think is a really strong use case for it. And so what we've built for the demonstration at the stall on the main event, it sort of rhymes with renewable energy credits. We're calling them human energy credits. And essentially, we've got a couple of exercise bikes. We've hooked up generators to them so they can generate electricity, and we're measuring how much energy they are generating. A little bit like how a household would generate electricity from their solar panels. We're aggregating multiple generation claims into a single issuance, and then issuing that on-chain with a link back to Holochain, so you can say, hey, this random person on Ethereum has issued some tokens. They say they are valid human energy credits. Prove it. Follow the link, go back to the application and see who cycled when to actually say, do you trust that credit or not? So, and there's lots of other things going in that space, but that's the store we've built up. So it's been a lot of fun. Also integrating the thing with Holochain as well, is because it's a lightweight client, like you can run it on really small devices. And I've got a bunch of Raspberry Pis acting as sensors, which are feeding into the application, which actually signs the things and integrates with the network. And I think that's probably my final message for you would be that often when you're going into Ethereum or blockchain land, you're going into an ecosystem which has made some very conscious trade-offs. Like we're going to prioritize security over everything else, so it's very expensive and it's very slow. Or you're going into one which is like, wait, we don't care so much about security, it's going to be fast and quick and whatnot. Whereas in Holochain, you can start to have a broader set of options, and you can decide yourself of, do you want strong security? Do you want easy usability? Do you want lightweight on the lightweight devices? Who are your users? How do you bring them in? And it just gives me this breadth of expression as a developer, which I found really valuable. So anyway, I'll be over here if you want to have a chat after this. Lovely to see you all, and come see our stall at the main event. Take care.